Alright guys, in this video we're going to be going over scatter plots and linear regression. I am going to show you some of these pretty quickly because it's mainly calculator tricks for this. So the very first one talks about this whole idea of response and explanatory. Remember, I always think of explanatory, you think of that X in explanatory. So you're saying which one of these would be the X value, and then the Y value is our dependent or our response variable. So looking at this guy right here, your explanatory value, or what is explaining everything, is going to be the average weight, because you're saying that the average weight is explaining the lifespan. So here's your X, here's your Y. Calculating an R value means that I need to be plugging all of these guys in to my calculator. So let's get that done. Get that calculator pulled up, let's clear everything out. You're going to click on Stat Enter to edit that. I'm going to go up and highlight L1 and just press Clear, Enter, and that'll just clear out all those values that we had put in there earlier. And as I go about, I'm going to put in all my X values into L1, so both of these rows, right? And then all my Y values into L2. I'm going to press pause here so I can get this done pretty quickly. After all these values are plugged in, you're going to go over here to Stat, and we're going to scroll over here to Calc, and we're just going to go and do this linear regression because that's what gets our R value. And once I press Enter, I realize that that is not there, so let's actually grab that. I'm going to click on Mode, and the idea is that your diagnostic needs to be on, because your diagnostic is what gives you this R value, or this R squared. If you do not see that in your mode menu, you can click on Second Catalog, and then you can scroll down until you see that diagnostic. And you can just go here and make sure you're clicking Enter to turn that diagnostic on. So after that, we're going to go Second Calc, Lin Reg, press Enter, get all that done, and here we go. Here is our R value. And I went in and I went back and changed a value. I realized I had typed a 7 instead of 73. But my R value is going to be negative 0.84. And remember, the R value is nice because the R value kind of gives you direction as well as strength. So this is going to be, I would say that this is probably going to be pretty strong, or moderate strong, and it's going to be a negative correlation. This leads us right into that line calculation. So remember, you're just you're just copying down these values. So your line is going to look like negative 0.027x, and then you're going to have plus that 13.8. So I'll get that written down really quick. And we can say that this is going to be pretty accurate because our R value was close. So we know that this is going to be a pretty good predictor because there was that strong relationship. When you are interpreting the slope and the intercept, what you're going to say is we're going to think about what are these X and Y values. So your X value, your explanatory, is going to be the weight. And then remember, your Y value is the average lifespan. Because it's looking right, this is a negative weight, or a negative slope, which means that the less my dog weighs, this is giving it the greater the weight, it's impacting that lifespan in a negative direction. So we're going to interpret this slope as saying that this is not going to be a great interpretation here, right? But at a weight of 0, lifespan is 13.8 years. Then we're going to say for every increase in 1 pound, the lifespan decreases 0.027 years. And remember what we're thinking about when we take this out. You're saying like, okay, that's negative 0.027 over 1. Remember that your slope is like y over x. So this is like lifespan. And then this would be your x value, which is weight. So every time this weight increases by 1, your lifespan decreases by about 0.27. When it asks us to create a residual plot, what that residual plot means is, remember, like what's the difference between the actual value and the predicted value, and that's what's graphed. So when I look at this guy right here, you can do a few things, but your calculator can do it for you. You're going to go to second y equals to go to that stat plot, and then where it says that y list, we're going to clear that out. First off, let's make sure it's that plot right here. And what I'm going to do now is I'm going to like say that I want my y list to be residuals instead of L2, because it automatically is going to say L2 and you want it to say residuals. So how I get that is I'm going to go to second stat, because that gives me that idea of like the list, and the list that you want is the resid. So we're going to come down here, and here's all the names of the stats operations, right? So like all of our lists are L1, L2, L3. But we want the residuals to be we want the residuals to be that response variable, and your x values to be that explanatory. So just like normal, you're going to go to that zoom 9, and here is our residual plot right here. Because I noticed that there's a good amount of randomness, I know that a linear model is strong because we have points that are going to be over-predicted and points that are going to be under-predicted, but like at no alarming trends. And if I were actually to grab this, so like let's say that we're going to look at the linear graph and not the residual graph, we can just come back here, and in that y list, we're going to go back to that second stat, and we're going to make that L2 so that we have that explanatory and response. And then again, that zoom 9. And then we can see that there's like really no curve, that a linear model is going to be a pretty good fit here. The rest of the questions are asking about just using that. So for example, we're saying like if a Shih Tzu weighs on average 13, approximately how long, you would be plugging 13 into that equation, into that like linear equation that we predicted, and I get 13.49 or about 13.5. But if its actual life is 12.5, then we're saying what is actual minus predicted to get that residual. So that's where that -1 comes into play. I want to go over 39 really quickly, because 39 is utilizing that r² value. And remember, r² is what percent can be explained, not like how accurate, right? I mean, like, yes, it is accuracy in a way. However, it's asking like percent explained, or like what percent of that variation can be explained. And so that's where that 72.2% comes from for number 39. The last little bit I want to look at in this video, everything else is like pretty self-explanatory, or you can do a quick Google. The last thing I want to look at is this kind of like transform, because like when you think about this like transform, it's not as scary as you think. So same thing, we're going to go to that stat edit. Whenever we have a list of data, most of the time we're plugging that into our stat edit menu. And then I'm going to press pause real quick, and we're going to get these values plugged in. So remember, your x values are going to be like the years, and then your y value is going to be the debt. All right, so after that is all plugged into your L1 and your L2, remember, you don't have to use 1980. You could have used 0, 1, 2, 3. You would just have to make sure that you knew that that was like years since 1980. So after I get that done, we're constructing a scatter plot. So same thing, I'm going to go to my stat plot, make sure that my plot is turned on. We're highlighting that scatter plot. And then I'm going to go to that zoom 9 so that it zooms it to the fit. When I look at this, this appears to be exponential because it has that slight curve. So if I were to look at, let's say that I was like, all right, let me actually calculate the linear regression for this. When I do that, here's why it's important to look at the data, because my R squared and my R value are pretty strong for linear, but I know that that's just because like that might change the further I go, because if we're saying that a line matches this data, exponential models have a tendency to start getting like really large, right? And kind of approach this vertical asymptote, or not approach a vertical asymptote, but it feels like that, right? Because it starts getting really tall. So I need to make sure that like you are checking your data for accuracy. So we're going to go back to that stat menu and go to calc. And we can come down here and play with some of the, we can play with some of this and say, like, let's look at a log graph, because that's what it asked us to do. So click on that B. Oh my goodness, and it did not like that. Let's see what it's saying. Well, it would appear that this logarithmic is for some reason not working on this calculator. There is like a limit to the online version sometimes. I'm just going to use a natural log and go with that. I notice here that I get a little bit better at values. Back into an exponential, same thing, guys. I would just come in here. Let's do to stat calc. You're just going to go down till you see that exp reg. It is not liking my exponential or logarithmic today, but those are the steps you would take to get there. All right, great, I fixed it. I had a hunch that like potentially what was causing the error was the fact that I was using like 1980. So I went and changed my L1 to be 0, 1, 2, 3, 4, 5. I think that like for logarithmic and exponential, it was just balking at this fact that usually exponential is like increasing at an increasing rate, right? Or like decreasing at a decreasing rate. So this whole idea that you could plug in 1980 and get an output of 0.9 was like a little ludicrous for it. So if we go here, now it looks like we have fixed that problem, and we are able to calculate my exponential and my logarithmic regression models. And then for exponential model to predict debt in the year 2000, what you can actually do is you can go back to that exponential regulation, and we can like store this regulation. If you go to second, or just click on vars and then click on yvars, I can actually store this into my y equals or my y1. So then when I go here, it's going to be there. So then when I can go to let's do zoom stat. Here it is. Oh, look, that fits much nicer. And I'm going to go to like second trace to go to calc, and let's calculate that value. In the year 2000, that'll be 20 years since 1980. I need to zoom out a little bit more. There we go. So then I can go back and let's calculate that value in the year when x is 20. It looks like my output's going to be about 11.988.